Okay, this video is going to be about kinetic energy. And in the last videos, we've been talking about how work and energy are very closely related. And so the first off, energy is conserved, so there's kind of this amount of energy that's out there, and we can't create it or destroy it. So we can only really transfer it from one thing to another, and the way that we transfer energy is through work, because work is the transfer of energy, and energy is the ability to do work. So when you do work on an object, you increase its energy, and that object can now do more work on something else. And there are many different types of energy, and we're going to talk about kinetic energy first. So kinetic energy is the energy of an object associated with its motion. And by that, I mean mostly velocity, but we'll see some other things come into play. So I guess the natural question is, how does something have energy because it's moving? And in the last video, we did an example where we had some balls that were moving through space, and a ball that is moving has kinetic energy, and that's because it can run into something, right? It could collide with something, and it could then apply a force over a distance on that thing and transfer some of its energy. And that would make it actually lose speed, right? Its velocity would decrease. So another way of looking at kinetic energy is the amount of work necessary to accelerate the object from rest to its stated velocity. And let's think about this a little bit. So, say I have a box that's initially at rest, and say we do this in outer space just so we don't have to worry about friction. And then I do some work on it, and eventually I get it moving, and now say it's it's got a velocity now. So what I've done is I've transferred energy to it because I've done work on it, right? Because I had to apply a force to it over a distance. I did work on the box. The box has more energy now, and now it's moving, right? And now that it's moving, it has kinetic energy. And the amount of kinetic energy that it has now was from rest, and now it's moving, is equal to the amount of work that I had to do on it to get it moving that way. And again, that should make sense from this work as a transfer of energy perspective. If it has zero kinetic energy, and then I do work on it, and I've transferred my energy to it in the form of kinetic energy, then the amount of work that I transferred to it should be the amount of kinetic energy it has, right? And that's kind of what we just said. The amount of work necessary to accelerate the object, so however much work I needed to put into it to get it to how fast it's going now, is equal to the kinetic energy that it has, right? That would be like saying the amount of energy that I transferred to it is the amount of energy that it has now gained. And so, some things to note about kinetic energy are we can calculate it, and the equation is kinetic energy equals 1/2 mass times velocity squared. And from this we can see that the faster and more massive an object is, the higher the kinetic energy. We also see that kinetic energy can never be negative, which kind of makes sense. How could you be moving in a way that means that you have negative energy? It doesn't really make sense. And we also see that in this v is squared, so even if it's negative, it'll become a positive number. And we can see that objects at rest have zero kinetic energy.